algorithm to find sum of even and odd numbers in between 1 and 10. For that, input is nothing, output is sum of even and odd numbers. We have to write between 1 and 10. After this is star, and we have declared 3 variables over here. One is counter to store even sum, that is eSum, to store odd sum, that is OSum. Both are initialized with 0. This is a variable declaration step. Next here, I is assigned with 10. It is called as assigning because we are giving value to a variable called as I after the declaration. Next, we have written one loop over here, that is while loop. In previous session, we learned about do loop, which was called as exit control loop. Now we have written while loop, which is called as entry control loop. Here the condition is I should be greater than 0. It means that the steps which are written within this while loop should be executed till the value of I is greater than 0. This is what it means. What have we have enclosed within while loop? If else statement and I equal to I minus 1. Now what happens? Now here I am finding out the counter is equal to even or odd. I am dividing it by 2 and finding out the remainder by making use of modulus. If it is 0, we decide it as an even number and this particular part will find the even sum. If it is not true, if this condition fails, comes to else part, we are going to decide the counter value as an odd number and we are going to find the sum. Here, we are decrementing the counter like 10, 9, 8, 7 and so on. After that, in step number 5, we are printing eSum and OSum, and here step number 6 is stop. This is the algorithm. Now we will learn how to trace this algorithm. I would like to trace this algorithm. So tracing is nothing but acting like a computer to find out whether I may get the intended output or not without feeding it to the system. Now let me trace. I would like to put one table now. This table will be containing variables, that is I, eSum and OSum. Let me write I over here, eSum over here and here OSum. Next, start, step 1 start. Step 2 declare, I have declared so many variables that there are 3 variables now. So remember, I is containing some garbage value because no value has been given over here. Next, this eSum has 0 and OSum has 0 because they got initialized. Next, it comes over here. Now, this I is assigned, not initialized, assigned with 10. Then it comes over here. Before getting into, it checks for the condition. What is there in I? What is there in I? You have a look on table. I has 10, right? You have to see the table. 10 is greater than 0? Yes. It gets inside. I is having 10. 10 more 2 is equal to 0? Yes, because if at all I divide 10 by 2, the remainder will be 0. That's why this becomes true. It gets inside. eSum is having 0 according to this particular table and I is having 10. That's why these two are added and 10 will be assigned to eSum. Now 0 gone, 10 is there under eSum. Let me put 10 under eSum. Do you think this else part is executed? No. It comes outside and we have one more instruction, that is I equal to I minus 1. Previously we used to write I equal to I plus 1. Now I have written I equal to I minus 1. Understood? Now I value will be decremented by 1. Where the control goes? It goes to this particular condition. What is there in I? We have 9. 9 is greater than 0? Yes. It comes over here. It comes here. 9 more 2. If at all I divide 9 by 2, there will be 1 remainder. Is it equal to 0? No. That's why it comes to else part. Here OSum equal to OSum plus I. What is an OSum? We have 0 and I is carrying 9. 9 plus 0 will become 9 and once again it will be assigned to OSum. OSum will become 9 now. Next it comes out. I becomes 8. Again goes back. What is there in I? We have 8. 8 is greater than 0? Yes. Gets inside. 8 mod 2 is equal to 0? Yes. It comes over here. What is there in E sum? E sum is having 10. I is having 8. 8 plus 10 will become 18. Now what is there in E sum? It is 18. Do you think it goes to elsewhere? No. Directly it goes out from the if control statement. I equal to I minus 1. I becomes 7. Now again goes back. I is carrying 7. 7 is greater than 0. Yes, it is true. Comes inside. Checks the condition. 7 mod 2 is equal to 0. No, because if at all I divide 7 by 2, I will get 1 as a remainder. It is not equal to 0. That's how it comes to else part directly. What is there in O sum? We have 9. And what is there in I? We have 7. 7 plus 9. O sum will become 16. It comes here. I equal to I minus 1 becomes 6. Again, the control goes back. Now, 6 is greater than 0? Yes. Once again, it gets inside. So, I becomes 6. 6 mod 2 is equal to 0? Yes. Here it comes. What is there in E sum? We have 18. What is there in I? We have 6. If at all I add 18 plus 6, how much it is? 24. Now, E sum becomes 24. Else part will not be executed. Please do remember, if executes, else will not be executed. If else execute, if is not executed. Remember. Next it comes over here, I equal to I minus 1. Now I becomes 5. Okay, goes back. I is greater than 0? Yes. Gets inside. I mod 2 is not equal to 0. Comes to L part. What is there in I? We have 5. What is there in O sum? We have 16. 16 plus 5 is 21. O sum becomes 21. Next, I equal to I minus 1. It becomes 4. Goes back. 4 is greater than 0? Yes. 4 mod 2 is equal to 0? Yes. It gets inside. What is there in E sum? Even sum. We have 24. What is there in I? We have 4. So, 4 plus 24, this E sum becomes 28. Right? Comes over here, it becomes 3. Goes back. 3 is greater than 0? Yes. Again, 3 mod 2 is equal to 0? No. Comes to else part. What is there in O sum? Let's have a look. There is 21. What is there in I? We have 3. 3 plus 21 will become 24. O sum becomes 24. Next, I equal to I minus 1. It becomes 2. Goes back. 2 mod 2, it is greater than 0. 2 mod 2 is equal to 0. It comes here. So, what is there in E sum? Let's have a look. 28 is there. What is there in I? We have 2. It becomes 30. So, let me put 30 over here. Comes outside. I equal to I minus 1. It becomes 1. Once again goes back. 1 is greater than 0? Yes. Now, please be careful. Now, if at all I get 4 mod 2, it gives what? 0. Remember, when left hand side you have greater value and right hand side you have a lesser value, then it gives what? Remainder. Remember this. I repeat, whenever you are making use of modulus, if at all the left hand side value is greater than the right hand side value, always it will give you remainder. If at all you have smaller value at the left hand side and greater value at the right hand side, remember the left hand side value will be given. It becomes 1. For example, you have 21 over here and here if you have 60, then what happens you know? You will get value that is 21. You have to remember this. Be careful. Now we have 1 mod 2. Left hand side value is less and right hand side value is more for this modulus. That's what it returns. It returns left hand side value, that is 1. Understood? That's why it is not equal to 0. Comes out, goes to else part. here, what is there in O sum? You have 24. What is there in I? That is 1. O sum becomes 25. Comes out I equal to I minus 1. I becomes 0. Goes back. 0. I is carrying 0. 0 is greater than 0? No. That's why loop is terminated. Comes to next step. Here what we have? Print esum, osum. What is there in esum? You have output will be 30 and 25. Now 30 is sum of even numbers, 25 is sum of odd numbers. This is how we trace algorithm. Here we have traced algorithm where we are going to find a sum of even and odd numbers in between 1 and 10, but we have started the counter from 10 to 1 instead of 1 to